Hey game devs, Dan here with You Contribute Games, and in this video we are going to talk about our follow path script. We've created a path to follow, and now we're going to tell objects in our game how to follow that path. All right, game devs, Dan here with You Contribute Games, and we're going to go ahead and dive on in. Today we're looking at our follow path script, but first let's go ahead and recap where we are so far. We've taken a look at how to set up the scene, how we utilize the follow path and the movement path scripts that we've built. And we've taken a look at how we set those up in the scene, where we've put some objects in the scene that have, these components on them, and we've set, how we can sync everything up and how we can use it, and how those different variables can adjust the movement and the functionality of these objects within the scene. And we've taken a look at the paths and how to create those paths within the scene using this, and we've dived into the actual movement path script itself to understand how that works and how that logic takes place. And in this video we're going to dive into the follow path script and exactly how that script is allowing the object to move from one point to the next. Okay, so let's go ahead and dive on in and take a look at the follow path script. And as always, we've used our standardized setup for breaking out our functions, our scripting into individual sections. So we have our enums, public variables, private variables, main methods, or our protected name methods for Unity. We have our utility methods, or our custom name methods, and then we have our coroutines, which are things that are going to run in parallel to other functions, right? So all right, let's break this out and take a look at each segment. First, we have our enums. We do have one enum that we're creating, which is our movement type, and that allows us to define if we're moving towards or lerping towards the next point in our path. All right. Within our public variables, we do have a few of these. We've got we're defining a movement type variable, so we're using that enum, and we're going to call it the type, and we set the default for movement type to move towards. The other option was lerp towards, right? So next we are setting a movement path reference. So we're going to call it my path, and it's going to be the reference to our movement path we use. So going back into our scene view, this is the reference we're setting up to the path, right? But ultimately what it really is it's a reference to this movement path script component. And that script, if you wanted, could be on any object. It could actually be on the sphere right here, and we could just reference to that and have those points referenced here. But for ease of understanding and getting that visual grasp of how it works, it's kind of easy to understand, okay, we have a path object, it's got a path script on it, and it has points in that path that we're following along, right? So that's just easy to understand and wrap your head around when you lay it out in that manner. Next, we're going to set up our speed variable and our max distance to goal. Now remember, that max distance to goal is just how close do we need to get to the next point in our path before we classify ourselves as arriving at our destination and decide, okay, time to move to the next point in our path. Remember, we don't move from point A to point B all in one frame. That spreads out over multiple frames so that it looks like we're moving there as the game progresses or as time moves on. So we need to check each frame and say, okay, are we close enough yet? Are we there yet? Are we at that point? And in some instances, when you do things like lerping or using linear interpolation, you never actually get to the point. You just get closer and closer and closer and closer and closer, right? To some magnitude or degree of closeness. All right, and so we have to rather than saying, okay, does A equal B, we have to say, is A within this amount of distance from B? So those are our public variables. We have one private variable, which is going to be a reference to the IEnumerator transform that is in our movement path, right? And that's the get next path point. So if you recall, that get that function or that coroutine is how we're grasping and we're saying, okay, this is where we are. What's the next point in our path, or what's the next point in our array? Okay, so that's how we're going to set a reference to that and allow ourselves to call that. Next, we have our main methods. So we're going to use the start and the update method. But before we dive into those, we'll take a look and we see our utility methods are empty. We don't have any of those, as well as our coroutines. We don't have any coroutines here for this scripting. All right, so let's go ahead and dive on into our start function, right? And really, our start function is going to get the ball rolling, so to speak. It's going to get us moving initially and get our, set us to those points and that we need to be at to start on our path. The first thing we're going to do is take a look and make sure that we actually have a path to follow. You can't follow a path if there's no path there. So we're going to do some due diligence and just make sure there's a path assigned. And if there's not a path assigned, then we're going to spit out an error message and just say, hey, movement path can't be null. I must have a path to follow. And then we're going to take a look and setting up our references. So we have a reference already to the path. Now we need to set a reference to that IEnumerator transform, or that coroutine that's in that. And that's what we're going to do here. We're going to set a reference to that coroutine get next path point. So once we have that reference set, we then need to call move next, which is going to get us to our first point in our path. So if we're actually looking at the the IEnumerator.moveNext method here on MSDN, and we'll pop this on screen for you. The move next method is going to as it says here, advances the enumerator to the next element of the collection. Well, cool. That just moves us to the next one. And in my rationale and the way I think about it, I'm saying, okay, we've got an array, or we've got a column of boxes, and it's going to move us from the box we're in to the next box in the sequence, right? So if we're in box 0, it moves us to box 1. If we're in box 1, it moves us to box 2, so forth and so on. But then if we look down here at the remarks, you can see after an enumerator is created, or after the reset method is called, an enumerator is positioned before the first element of the collection. So what that means is, in my mind, I'm taking a look at our scene view, and I'm saying, okay, we have a path sequence, right? And this is an array of 4 elements. Well, if I'm looking at an array starts at 0, so we've got element 0, element 1, element 2, element 3, and that's kind of why we've named these P0, P1, P2, P position, 1, 0, 1, 2, and 3, is so that it kind of correlates in our minds to that array. But once that was just created and we set that reference, we got our initialization, well, we're not at point 0 yet. It says it positioned us before the first element. All right. And then it goes on to say, and the first call of move next method moves the enumerator over the first element of the collection. So it's going to move us into this first element. All right. Well, cool. Now we're at position 0, and we're then going to say, all right, we're going to do some due diligence. We're going to make sure there's a point in this path, and we're going to say, if the current point that we're at now, we've just moved to 0, is null, we're going to debug out and say, hey, a path's got to have points to follow, right? And we're going to return and exit out of that, not going to stay in it. And once that's done, we've set up our points. We've got everything started. We're at point 0. We're going to go ahead and set our position, or the object that we're moving's position, to the current position we're at, to that element 0, or that point 0. If that's a little confusing for you, a good way to easily see this in action and understand how that sets up and how that move next works, a good thing we can do is go ahead and let's drop in some debug code here. So I am going to drop in a debug right here, and we're just going to say, okay, what's the current position we're at, right? And then we're going to move next, and we're going to say, what's the current position we're at? Okay, now let's save that, and then we'll go ahead and switch on back over here, hit play. And as you can see, once that starts and it goes into play mode, you can see that once it's first created, it shows null for the current position. We call move next, and it sets our point to 0, right? Well, let's go ahead and stop that. And the other thing we did within our script was to go ahead and then move ourselves to that current position. So now we've said we've moved next. Our current position, as you saw, was now 0. And we're then going to make sure that that point isn't null, okay? And then we're going to set our position, our object's position, to that point. Well, that gets us on the path. So it doesn't matter if we want to go ahead and let's grab this sphere, and we're going to drag that sphere way over here. Well, now once I push play, you saw that sphere automatically started at point 0. So even if we're slightly off from that point, we're going to be right there, okay? Let's get that pushed right back where it was, and then let's dive back into the code. So we've got our ball rolling, we're on the path, we've got our path initiated, and then every frame, what's going to happen? So every frame our update is called, and the first thing, again, we're doing our due diligence, and we're going to validate that there's a path, just in case for some odd reason it got lost from the object, it got deleted, whatever the case is, we've still got our path. Otherwise, we exit out of update. Now, we then are going to decide, okay, are we moving towards our next point, or are we lerping towards? And again, that is based off of us setting this type value here, move towards and lerp towards. And within each of those, we're going to use either the move towards, the vector3.moveTowards function, or the vector3.lerp function. Okay, and since this is happening over time and not instantly in the frame, we're doing that over time.delta time times the speed, so that it provides us a smooth visual, as the frames progress and as time progresses. All right. Once it reaches that point, we want to move on to the next point, right? So in order to determine if we've reached that point, we need to know the distance between where we're starting and where we're finishing, all right? Or where we're at and where we're finishing. Now, in order to identify that distance and then compare it to that max distance, we need to do a little math here. And a good way to kind of follow that is to use the Pythagorean Theorem. And I know I've probably mispronounced that, and I'll probably mispronounce it another dozen times, but we're going to look at that right here. And as you can see, if you recall from algebra, geometry, trig, whatever it was, we can identify the points, the distance of points on a triangle, or the sides of a triangle. It's how a squared plus b squared equals c squared, right? So if you square side A, add the square of side B, it's going to tell us the the third side squared, it will equal that third side squared. So we can kind of use that logic and that equation, or one of the variants of that. All right, so we've got a couple variants here of that formula, and within those variants we can then kind of calculate the distance and then use that to say, okay, we have our max distance, and is that close, are we within that max distance to the point we're moving towards, right? But there's a kind of a gotcha here, because Unity offers a couple different functions, right? We've got our vector3.distance, which, let's throw that up on screen and we can take a look at it. The vector3.distance is going to return the distance between A and B. So if we were to say, vector3.distance and provide it the transform position of where we are and the transform position of where we're going, that's going to give us a distance. And then, if you look here, it's going to also, the vector3.distance is the same as, the A minus B magnitude, right? Well, the big thing here, if we flip over to magnitude, is that we can see this is going to use the square root. And per Unity's documentation, if you only need to compare magnitudes of some vector, you can compare squared magnitudes of them using the square magnitude. Computing squared magnitude is faster. And then when we look at the squared magnitudes, you can take a look and say, see where it's discussing, it says the magnitude of a vector is calculated as, math f dot square root of vector 3 dot dot of 2 points. However, the square root calculation is quite complicated and takes longer to execute than the normal arithmetic operations. Calculating the square magnitude instead of using the magnitude property is going to be much faster. The calculation is basically the same, only without the slow square root call. So if you're going to compare the distance between 2 points, it's going to be faster to use square magnitude rather than magnitude, or its other variant of distance, right? So that being said, here within the template I've provided, I've gone ahead and commented it out, but I've given you an example to show, we can use the vector3.distance function to compare 2 points, right? The point we're at and the point we're going to. And then we can say if the distance squared, what we've just calculated, is less than our max distance, hey, we're close enough to the point, and we can call our move next to move us to that next point. But that's going to be slower than using square magnitude, right? To some degree. And if you're doing this every frame and a lot, you kind of want to optimize that. And this is just a quicker option. So we can say, distance squared is going to be the square magnitude of our current point minus the position we're moving to. And then we want to say if that distance squared, which was the square magnitude we calculated, is less than, and again, we're going to need to determine the square magnitude of our max distance to goal. So we're going to square it. Max distance to goal times max distance to goal, right? And if it is less than that, then we're close enough, and we're going to move to the next point in the path, or set our path, call path_point.moveNext. It's going to move us to that next sequence, or loop through our enumerator, our coroutine again, and get us that next point that we're going to move to. And that's it. That is all there is to it, guys. If you're following along and trying to type this up, I know it's annoying to try to skip and scroll through the video to find where I was at what part, so that you can get that, type up that one little section and pause it during that, half a second while I showed that section. So what I'm going to do here is scroll through the code kind of slow, give you a good opportunity to see it start to finish, pause where you need to if you want to type this up. but you don't have to. If you'd like, head on over to youcontributegames.com. Click this link right here. It's going to take you over to You Contribute Games, where you can sign up for our newsletter, where we simply, we use that list to notify people who are interested in our material when new awesome content like the video you're watching right here comes out. But you can go ahead and sign up for the newsletter, download a copy of the asset pack that I've been using in this video absolutely free of charge. It's got this script as well as the MovementPaths script and the demo scene that we've been using with the sphere and the capsule and the block and the MovementPaths and everything. It's going to have that whole scene already set up along with the scripts so that you can get a copy of this and use it in your own games without having to type it up yourself, without having to go through that whole exercise. Feel free to use it. Go ahead and click the link right here if you would like. But again, you don't have to. You can go ahead and type this up. It's so hard to say goodbye to this video. Ooh. All right, guys, that's it. Go ahead, like us on Facebook, follow us on Twitter, click that subscribe button, leave us a comment, let us know you like what we're doing. Talk to you next time.